Welcome to the video tutorial of the Bayesian inversion plugin for Petrel, developed by Ltrace Geophysical Solutions. The plugin is a Bayesian seismic inversion for the estimation of the elastic properties from angle stack seismic data. The method computes the maximum posteriori solution of the seismic inversion problem. It is a very fast methodology, and the plugin is implemented in CUDA library for accelerating the inversion by using NVIDIA GPUs. The plugin allows the user to select a horizon to define a stratigraphic grid where the solution is computed. Real-time quality control is also available to compare the selected well logs to the inverted properties. The user can find the plugin in the seismic interpretation or quantitative interpretation tabs. The first fields to select are the seismic cubes and wavelets. For each seismic cube, the user have to input the average angle, the noise level, which is defined by the standard deviation of the seismic noise, and the wavelet, which can be scaled by this factor. Click at the Add button to insert the data and then select the other seismic cubes. By clicking in the rows, the user can change the parameters and clicking Update button to save. The low-frequency models, also called trend models, are inserted in these fields. By default, the plugin uses the Aki-Richard equation for reflectivity. Therefore, the trends of velocities and density are required. The user can choose to use the FET equation, then the trends and results will be impedance instead of velocities. The range section allows the user to select a subvolume to run the inversion. The section of standard deviations is where the user selects the uncertainty in respect to the low-frequency models. If your results are too smooth, you may need to increase these values. Next, the user selects the correlations between the properties and also in the horizontal and vertical directions. The last part is to input the names of the output objects. There is also the option to override previous results in case the user does not want to generate new results object for each run. In the Layers tab, it's possible to select the horizon, which will serve as a base for the stratigraphic grid. The user needs to input the shifts upwards and downwards of the horizon, which will form the time interval for running the inversion. The random line field is where the seismic line 3D is used to select the trace gate for the inversion. In the QC tab, the user selects the wells for comparison with the inversion results. Global well logs are selected for time and the inverted properties. The selected wells will be searched for logs that match the selected global well logs and displayed at the QC window. The layers and the QC tabs are optional. By clicking Run, the plugin will show a warning if your horizon with the shifts crosses the boundary of the input volumes. The progress is displayed at the bottom, with an option to cancel the inversion. The QC window shows the well logs along with the inversion and the respective correlation coefficients. The user can select to view the correlations of all wells or for the selected well only. If the window is kept open, when a new inversion is run, the plots are updated automatically. You can also see the results at the 3D window. As we have selected the random line, the results are 2D seismic lines. We see that the inversion results are coherent with the well logs also in 3D. Thank you for watching this tutorial. Contact us at support@ltrace.com.br for questions on the plugin.